Hello, this is Jason from Group 5, and today I'm going to make a video about the second object measurement for this project. So as of right now, I got over here is our second object, which as you can see over here is a cup. And in this cup, I have already had a cable tie stuck into it so that it can notify me, it can act as a starting point and the end point of the cup. It's like an indicator that shows me where it starts. So basically what we have right here is a rack, a baking rack, and I've poured a lot of salt into it. And what I'm going to do is I'm going to roll this object that I have right here for one revolution only. And how can I tell if it's one revolution? It's simple because of the indicator that I have highlighted, that I have stuck into over here. So basically when we complete one revolutionary, I will make a indicator. I would indicate where's the starting point and where's the end point, and then we'll use a tape measure to measure from there. So first we're going to measure the circumference of this cup. We're going to do it 3 times, and then I'm going to find the average of all 3 to find the circumference for the cup. So we will start here. As you can see, there's an indicator right here, and I will make this indicator. As you can see, it is not visible, as you can see over here. Yeah, so it starts right over here, and then I'm going to roll for exactly 1 revolution. And since this salt surface is kind of hard to get like a straight rolling motion, I will have to use my hand to assist it. Okay, so we will begin. Got it. As you can see, I'm gonna highlight it, the endpoint. As you can see, we have the endpoint and the starting point. And for now, I'm going to go ahead and use so we're going to measure the first try. And as you can see over here, we get exactly 10.75 inches for the first try. So I will note this in as 10.75 for the first time. Done. And now we're going to shake to restart the module, and then we're gonna start again. And I will show you everything, of course. Okay, so we're gonna highlight, first of all, highlight the starting point. As you can see over here, get the starting point. And we are going to roll for 1 revolution. So here we go. So we're done with the endpoint. I'm gonna quickly highlight it here. Got it. So this will be the endpoint. As you can see, I've highlighted it. And I'm gonna put the cup aside, and I'm going to measure it 1 more time. Actually 2 more times. So for this one, we actually get 11.25. So I'm gonna quickly note it. 11.25. Okay, gonna make this even faster. Reset it and place it. Gotcha. Get it over here. Actually over here. Gonna highlight it, and I'm gonna roll. And we're here at the end point. as you can see, endpoint and the starting point over here. Okay, for this circumference. Okay, so for this one, we actually get 10.75 again. Okay, so I'm gonna quickly note that. 10.75. Gotcha. We're gonna continue to find the average of the three. So as you can see, I have my calculator here. I will put 10.75 plus 11.25 plus 10.75 and divide by 3 to find the average and also like the correct number, the more correct result for the circumference, which I got over here is around 10.916, which we can correct it into 10.92 for the circumference. 10.92 for the circumference. And also to find the uncertainty of this circumference, I will use the same method that I have used for the first object, in which I would use the result, which is the 10.92, or I can just go ahead and use this number right here, and then I would subtract it with the one number that is the most further away from that 10.92 number, in which case it will be, so the most further from 10.92 is actually 11.25. So we would use 11.25 minus 10.92, and we will get the uncertainty of 0.33. So it will be, so the correct result for the circumference of this cup, this cup would be 10.92 inches with a plus and minus 0.33 inches. And yes, we are done with the circumference, and now we're moving on to the diameter. Okay, so we are moving on to the measurement of the diameter. With the diameter, I would say it is fairly easier to calculate, although we do have to make sure that the measurement should avoid as much uncertainties as possible. And how to do that basically means you have to keep the tape measure as straight as possible to keep it away from getting any uncertainties. So basically what we would do for this measurement is we would measure it from one end to another end, and we have to make sure that it's a straight line. It has to be straight. Yeah, so it just has to be straight. But yeah, it's pretty straightforward, and we will get right into it. So I couldn't really get an angle as good because I'm recording by myself. So I think we're gonna have to deal with it. And okay, we're gonna start with one part here. Yeah, we get exactly 3.5 as the diameter. For this measurement, I would say the only uncertainty that may happen is the metal tip on, basically the metal tip on the tape measure that can possibly, as you can see over here, it has like an extra edge over here, and that I think can possibly change the outcome of this experiment. So I would say it is around 0.1 inches long. So the uncertainty will be done. So the uncertainty will be around 0.1 inches. So in whole, the diameter of this cup would be 3.5 inches with an uncertainty of plus and minus of 0.1. And there you have it. That is the measurement for the object 2. This has been Jason from Group 5. Thank you for listening and watching.